Okay, so now we will see the graphical representation of the trigonometric ratios. Okay, so graph looks very interesting. So let us see what we are going to do. So let us try to first plot. What am I going to do is I am going to have a graph. Let me take your x-axis is a theta. Okay, your x is theta and this is minus theta. Okay, and I am going to plot your sine theta here along these two lines. So this is actually your x, this is minus x, y and minus y. Okay, I am going to plot sine theta on this graph. So let me write it x only, so it's a bit confusing. Let me write it x and minus x. So in x I am going to plot theta and I will see what is going to be my value of sine theta. Let us try to first plot the sine. So this is 0. Okay, so along the x-axis, so my x-axis is going to be theta. Okay, and along the y I am going to plot sine of theta. Okay, so let us first take theta equal to 0, that is here. Okay, theta equal to 0, what is sine? Sine is also 0. So let me use another color. So let me use a blue. So theta equal to 0, sine is also 0. And then, so when theta is equal to pi by 2, let me write here pi by 2. Okay, so sine becomes, so if this is 1, okay, sine becomes 1. Okay, and then pi by 2, so let us, then when it becomes 0, pi. So then next I am going to have here pi, so at the pi, sine becomes 0. Okay, so in between it has a different value, so 1 by 2 and also it is going to have a shape something like this. Okay, it will not be like, it's a very smooth curve. I am not able to draw the smooth curve, so let us try to see like this. Okay, yeah, so now at pi, where we are there, at pi sine becomes 0. Next sign is going towards the negative sign. You got it? That means downwards. So when it becomes negative 1, that is become 3 pi by 2. That means when it is becoming 3 pi by 2, this will become negative 1. Okay, it's here. So let me extend the axis. I made it too small. Okay. Okay, and then when it becomes it becomes minus 1 at 3 pi by 2. Where is 3 pi by 2? Where we have 3 pi by 2. 3 pi by 2 become minus 1, and then again this becomes 0 at 360 degrees. That is at 2 pi. Correct? 2 pi. Where the cycles? Correct? So this is going to be, so the curve will go something like this. Okay? So this is in the positive theta. Now let us plot for the negative theta. So how the negative theta will look like? What will be negative theta? Because we know sine of minus theta equal to minus sine theta. Okay, so let us take here 1. So okay, so sine pi by 2 is equal to 1. So sine of minus pi by 2 equal to minus 1. Correct? Right. So this value is going to be minus pi by 2. So for minus pi by 2 it is going to be minus 1. Correct or wrong? Okay, and then next minus pi by 2, and then let us go for next value, that is equal to pi, minus pi. Okay, what will be minus pi? For pi, where is our pi? Pi is here. Sine is 0. Okay, so the curve will go like this. Sorry, I'm drawing like a straight line because in between these values will come. Okay, so you can find out the values of that and you will see it will not be a straight line, it will come like a curve like this. Okay, and then let us go for the next one. What is that? Pi by 2, pi, then I am going to plot minus 3 pi by 2 and then minus 2 pi. Correct? So 3 pi by 2. Where is 3 pi by 2? Where we have 3 pi by 2 here? 3 pi by 2 here. Okay, 3 pi by 2 is minus 1. So minus 3 pi by 2 will be equal to minus of minus 1. So that is going to become 1. So this will be here 1. Okay. So and then 2 pi will be again complete 0. It becomes 0. So this is your sine. Okay. It keeps oscillating kind of curve. Okay. So this is your sine curve. So it will be interesting to plot cos curve. What will be the cos curve? And we can plot it above the sine curve itself. It looks very nice. So how the cos curve looks? Let us see. I am going to use red color. So the blue color is for, this is for, So this is for sine theta. Sine theta, and then I am going to use a red color for cos theta. Okay, so let us for cos theta. So for cos theta, so next one, 0 is equal to 1. That is positive 1 here. And then when it goes to 0, pi by 2. Correct? So it goes to pi by 2, it becomes 0. So the cos goes like this. Okay, and then when it becomes 0 here, and then it becomes minus 1 at pi. So means at pi it is going to become minus 1 here. Am I right? So this will go like this. And then again at 3 pi by 2. 3 pi by 2 it is going to become 0. So this will go to 0. Okay. And then what happened there? 2 pi. When it becomes 2 pi, that is equal to 0. That is going to become 1. That is here. Correct? Okay. And let us plot for the negative theta. So what is negative? Because we know cos of minus theta is equal to cos theta itself. So it doesn't matter. So same is going to happen here. Okay. So let us see. So minus pi by 2, all you have to do is the same pi by 2 value. What is the pi by 2 here? That is 0 here. Okay. So this is going to make it as 0. And then for minus pi is nothing but same pi, that's going to be minus 1. Okay, so this will be here. Okay, and then 3 pi by 2 is going to be 0. So this will be a curve will go like this. Okay, and then for 2 pi again it makes complete circle, that is going to be 1. So we will have something like 1 here. Okay, so this is how your cos curve, cos function and the sine function looks in terms of theta. So if you see carefully, this is nothing but they both are just shifted. Am I right? They are shifted back. So if I just add up at the pi by 2 with sine cos theta, suppose this is a cos theta, right? If I add a pi by 2 angle to cos theta, it just goes and overlaps with the sine. Okay, so basically if it's sine pi by 2 plus theta will become cos theta. Okay, that formula comes. You can, I don't know whether you had it in earlier class or what. It's okay. Anyway, we don't have to bother. This is a way. So what they call is, this is a phase difference they call. So the sine and cos always they have a pi by 2 out of phase. Okay, they just because see this peak and this peak differ by pi by 2. 0. So always there is a pi by 2 out of phase. Sine curve and cos curve, but they both are oscillatory curves. Okay. So let us. Now we will plot for tan theta. Okay. So what will be the tan theta? So we are going to have x-axis. Tan theta will be slightly complicated. Okay. So we will see x. This is minus x, and then we are going to have y. This is y and minus y. You will see in tan theta it makes an infinity jump. Okay, so that's something we have to understand it. So let us see. So what we are going to do, so let us start with the tan theta. So I'm going to use blue color for tan theta. At 0 degree, tan theta equal to 0. So we are having 0, pi by 2, pi, 3 pi by 2 and 2 pi. Okay, so at 0, tan theta equal to 0. At pi by 2, if you see, where is the pi by 2? here it goes to infinity. That means, so let me draw these lines are at these values tan theta, and similarly for 3 pi by 2 also we have infinity. So at these values tan theta is not defined. Okay. So now, so from here if you see 0, it keeps increasing. 0, 1 by root of 3, okay, it keeps increasing. Okay, and goes large up to infinity. So for the value tan theta will go something like this, but it won't reach there because it will reach there at infinity. Okay, we never know this is. And now, if you see, when you go beyond that, that's infinity. Suddenly it starts from negative, correct? So if you see, actually this from here, when I go forward, so the value will come from negative to because that pi is again equal to 0. You got it? At pi equal to 0. So now this is negative value because minus 3 is larger than minus 1, which is minus 3 is smaller than minus 1, minus 1 is smaller than minus 1 by 3. So it goes like this, and from here it makes an infinity jump. That's what, from positive infinity to negative infinity, and then it makes a jump like here. This is 0, correct? So this will be the, it doesn't touch the line, okay, because that's undefined. So this is how your tan curve looks like. So then let us go forward. Then again, for when I go ahead of pi, this is going to increase, right? 1 by root of 3, 1 and root of 3, so it's going to increase. And then it's going to go for minus infinity. Whatever it's going to increase here, it goes increase and suddenly jumps to minus infinity. Okay, so the curve will go like this. Okay, and then suddenly jumps to minus infinity to come back, then again come back to something like this. Here it is 2 pi, so it comes like this. So this is so tan function always makes this jump from minus infinity to plus infinity and plus infinity to minus infinity. Okay, so you got it? So now let us try to go for the other side. So this is going to be minus pi by 2, and then we have pi, and then we have minus pi, minus 3 pi by 2, and then we have minus 2 pi. Okay, so yeah, so tan minus theta equal to minus tan theta. Okay, so tan, okay, so then what happens? So here also, again in the pi by 2, we don't have a, because pi by 2 is again infinity, so of course minus pi by 2 is also going to be infinity. All these values, tan function is not going to be defined. Okay, so then now you see, so now I am going for this value here, right? So 0 to minus pi by 2. That means I am going from 0 to minus pi by 2. So this, for a positive, it goes positive direction, right? When I take negative, this will be minus of this. Am I right? So this is going to be minus 1 by root of 3, minus 1, minus root of 3 to minus infinity. So this will go something like minus value. Correct? And then when I okay, so it's reaching infinity. Okay, so then it's going to be minus, right? But when I take minus of tan, I mentioned it's going to be minus of, negative of, minus of minus. So it's going to be root of 3, 1. So it's going to be larger value to smaller value. Okay, so that means from larger value, so it's going to again make a jump from minus infinity to plus infinity, and then make a curve something like that till that it reaches 0. Okay, and similarly you can see, so this will go like this. Okay, and again if you see this from always it makes an infinity jump. Okay, so this will be the okay, so this will be goes like this. So this is your tan, how a tan function looks. Graphical representation of tan function. It looks good, right? Yeah. So now let us go for, let us over this we'll plot cot. So let us see how cot looks in this over the plot. Fine. So cot interestingly starts with infinity at 0. Okay, and when it becomes 0, at pi by 2 it becomes 0. Okay, so this is something like it goes from and we can see it's all are positive, correct? So from root of 3 to 1 it goes smaller, okay, up to 0. So let me note it down. So this blue line is your tan theta, and now we are going to plot the cot theta. So cot theta will be at pi by 2, this is 0. When I go less than pi by 2, it is going to be positive and goes to infinity. So this will go something like this. Okay? And then pi by 2. After pi by 2, what happens? With pi by 2, cot theta is going to become negative sign. You got it? So this is going to be in the negative direction. And until, and see, I forgot to make the lines for cot theta. So these are the undefined places for cot theta. Okay, because cot pi is again infinity if you see. Okay, so and these are all the undefined places of cot theta. So now again this goes in the negative side. See, if you go greater than pi by 2, it goes to negative side and reaches the minus infinity. So it goes like this. Okay, it won't touch. Okay, it should never touch because it touches at infinity only. And then from there it makes another positive jump because it comes to positive value. See, suddenly from minus infinity it going to positive value. So it starts from plus infinity. It makes a minus infinity to plus infinity jump, and then it keeps like this, and then again you can go like this. Okay, the same way you can plot for here also. So you get inverse of it, so that will be minus sign. So then, so you can, it will be same form. See, if you see the same form repeats, right? So just reverse of it. So what it will going to happen? Tell me. Yeah, so now cot of minus pi by 2. Cot of pi by 2 is how much? 0. So this is going to be 0. Okay. So let us go for lesser value. This 0. So this is all going to be negative. Am I right? Because cot of minus theta equal to minus cot theta, inverse of tan. Okay. So this is going to come like this, and then if you can see, it will go like this. Okay, and then again this will come like this, and it will go like this. Okay, so this is your which function? Tell me. What? Cot theta. Okay. So this is your graphical representation of a tan theta and cot theta. So we already signed theta. So let us try to plot cosec theta. So what will be cosec theta? Okay, fine. Cosec theta is interesting. So let us say cosec theta. Cosec theta at 0, it goes to infinity. So cosec theta is not defined at 0. Okay. And cosec theta becomes 1 at pi by 2. So it becomes 1 as pi by 2. Okay. So it's from infinity, it is going to come like this. Am I right? Okay, so cosec theta will come like this. Oops. Okay, and then where it reaches 1, then again going to go above 1. Am I right? Till it reaches infinity at pi. So at this pi, this is going to be undefined. For cosec theta. Okay, and then so it reaches infinity, then from there suddenly it jumps to negative, correct? And then reaches up to minus 1. So it jumps from negative, so it goes like this. So it won't touch here, and then comes like this. You can see. So if you see here also it will be the same way. So this won't be because just a negative sign it will be. So the figure will be, the plot will be exactly reverse side. Okay. So now here this is going to be inverse of this. This is above, so this will be reverse. Inverted it. Okay. And then here this will be your. So this is your what function? So this is your cosec theta. Can you tell me what will be cot theta? Cosec theta?
The same.
Yes, exactly. It will be reverse of it, right? Sec theta will be 1 at 0. Okay. So, but then it reaches to pi by 2, it becomes infinity. So exactly for sec theta, these are the values, because pi by 2s will be at all pi by 2, odd number of pi by 2, it's going to become infinity. Okay. So for cosec theta, sec theta, these values are undefined. Okay, similarly I can, because cosec theta sign is going to be same. Okay, because for minus cosec of, sec of minus theta equal to sec theta. Okay, yeah, so then what it will be? So this will go like this. Good? And then again from here, and yeah, it is negative. Okay, so this will go like, go like this. Okay, and here again this will be going like this. So this is this curve is your sec theta. Okay, so this is the way, this is how trigonometric functions, the graphical representation of trigonometric functions will be looked like. Okay, so